Hello friends, welcome to our student support program for grade 11. At the end of a lesson, you will apply differentiation to small increments or changes and approximations. So let's begin. A quick recap of first principles. Given a function y is equal to f of x, let p be hk. Suppose h is changed by an increment delta x to become h plus delta x. Then k changes by an increment delta y. As delta x tends to 0, dy by dx will tend to delta y over delta x, which is equal to dy by dx is approximately delta y over delta x. If delta x and dy by dx at point P, H, K are given, then delta y can be calculated. Dy by dx at x is equal to h is approximately delta y over delta x. Cross-multiplying and making delta y the subject of formula, we get delta y is equal to dy by dx at x is equal to h multiplied by delta x. Let's apply this rule to some examples. Example 1. Given that y is equal to 7x squared plus 4x minus 7 and x increases from 2 to 2.01, find the increase in y. Dy by dx is equal to 14x plus 4. Initially, x is equal to 2. Substituting this value in dy by dx, we get 14 multiplied by 2 plus 4. Evaluating this, we get 32. Delta x is equal to 2.01 minus 2, which is equal to 0.01. And dy by dx is equal to 32. Substituting these values to get delta y is equal to dy by dx at x is equal to 2 multiplied by delta x. Substituting the values, we get 32 multiplied by 0.01, which is equal to 0.32. Example 2. Given that y is equal to 2 over x cubed, if x increases from 3 to 3.2, part A, find the approximate change in y. Part B, find the new value of y. First, we rewrite our function. Y is equal to 2x to the power of negative 3. Dy by dx is equal to 2 multiplied by minus 3 multiplied by x to the power of minus 4. Dy by dx is equal to minus 6 over x to the power of 4. Initially, x is equal to 3. Substituting this value in dy by dx, we get minus 6 over 3 to the power of 4. Evaluating this, we get minus 2 over 27. Delta y is equal to dy by dx at x is equal to 3 multiplied by delta x. Substituting the values, we get minus 2 over 27 multiplied by 3.2 minus 3. Evaluating this, we get minus 2 over 135, which is equal to minus 0.015 rounded off to 3 SF. Note that a negative delta y indicates a decrease in y. We can also write this answer as decrease in y is equal to 0.015. When x is equal to 3, y is equal to 2 over 3 to the power of 3, which is equal to 2 over 27. New value of y is equal to initial y plus increase in y. From part A, delta y is equal to minus 2 over 135. Substituting these values, we get 2 over 27 plus minus 2 over 135. Evaluating this, we get 8 over 135. Example 3. Given that y is equal to sine 4x, part 1, find dy by dx. Part 2, hence find the approximate increase in y as x increases from pi by 12 to pi by 12 plus p, where p is small. Y is equal to sine 4x. dy by dx is equal to cos 4x multiplied by differentiation of 4x, which is equal to 4 cos 4x. Second part. Approximate increase in y. Delta y is equal to dy by dx multiplied by delta x. dy by dx when x is equal to pi by 12 is equal to 4 cos 4 pi by 12. Note that your calculator should be in radian mode. Evaluating this, we get dy by dx is equal to 2. Delta y is equal to 2 multiplied by pi by 12 plus p minus pi by 12. Simplifying this, we get 2p. Example 4. Given that y is equal to ln x over 3x plus 1, part 1, find dy by dx. Part 2, find the approximate change in y as x increases from 1 to 1 plus p, where p is small. First, we label ln x to be u, 3x plus 1 to be v. We write down our quotient rule. dy by dx is equal to v du by dx minus u dv by dx over v square. If u is equal to ln x, du by dx is equal to 1 over x. If v is equal to 3x plus 1, dv by dx is equal to 3. Substituting these values, we get dy by dx is equal to 3x plus 1 multiplied by 1 over x minus ln x multiplied by 3 over 3x plus 1 to the power of 2. Simplifying this, we get dy by dx is equal to 3x plus 1 minus 3x ln x over x multiplied by 3x plus 1 to the power of 2. Approximate change in y is equal to delta y equal to dy by dx multiplied by delta x. dy by dx is equal to 3x plus 1 minus 3x ln x over x multiplied by 3x plus 1 to the power of 2. When x is equal to 1, dy by dx is equal to, substituting the value, 3 multiplied by 1 plus 1 minus 3 multiplied by 1 ln 1 over 1 multiplied by 3 multiplied by 1 plus 1 to the power of 2. Evaluating this, we get dy by dx is equal to 1 over 4. We rewrite our delta y, which is equal to dy by dx at x is equal to 1 multiplied by delta x. Substituting the values, we get delta y equal to 1 over 4 multiplied by 1 plus p minus 1. Simplifying this, we get p over 4, which is the change in y. Example 5. The radius of a circle increases from 5 to 5.02. Part 1. Find increase in area. Part 2. Find new area. Let radius be r and area be a. A is equal to pi r square. dA by dr is equal to 2 pi r. When r is equal to 5, dA by dr is equal to 2 pi multiplied by 5. Evaluating this, we get 10 pi. Delta A over delta R is approximately dA by dr. Cross-multiplying and making delta A the subject of formula, we get delta A is equal to dA by dr at R is equal to 5 multiplied by delta R. Substituting the values, we get delta A is equal to 10 pi multiplied by 5.02 minus 5. Evaluating this, we get delta A is equal to pi over 5 centimeter square, which is the increase in area. Now to calculate the new area, we need to take initial area plus increase in area. Initial area is equal to pi 5 to the square, which is equal to 25 pi centimeter square. And increase in area is pi over 5 centimeter square. Therefore, the new area is equal to 25 pi plus pi over 5. Evaluating this, we get 126 over 5 pi centimeter square. Now that we have done a few examples, you can try these exercises on your own. Number 1. The equation of a curve is y equal to 4x cubed plus 11x squared minus x plus 7. Write down an expression for dy by dx and hence find the approximate change in y as x increases from 1 to 1.04, stating whether there is an increase or decrease. Number 2. The equation of a curve y is equal to 5x squared plus 16 over x cubed. Part 1. Obtain an expression for dy by dx. Part 2. Use your expression to find the approximate change in the value of y when x increases from 3 to 3.01. Number 3. The volume v centimeter cube of a sphere of radius r centimeter is given by the formula v is equal to 4/3 pi r cube. Air is leaking from a spherical balloon. Use calculus to determine the approximate decrease in volume as the radius decreases from 20 centimeters to 19.8 centimeters. You may leave your answers in pi. Number 4. A curve has the equation y is equal to x to the power of 4 ln x, where x is greater than 0. Part 1. Find an expression for dy by dx. Part 2. Find the approximate increase in y as x increases from e to e plus p, where p is small. Number 5. Given that y is equal to cos 5x, part 1. Find dy by dx. Part 2. Hence, find the approximate increase in y as x increases from pi by 10 to pi by 10 plus p, where p is small. Here are some links that you can visit to help you with this lesson. So friends, today you have learned how to apply differentiation to small increments or changes and approximations. I hope you have enjoyed the program. Till next time, it's goodbye.